Hi, hello, I'm Kiran Kumar from Nature of Physics and Art. Welcome back to my channel. Today topic is electric field intensity on the axial line and equatorial line of a electric dipole. I will find with the help of EVD relation. E is the electric field intensity, V is the potential, D is the distance. From the electric potential formula, electric potential V is equal to Kp cos theta divided by R square, where K is equal to 1 by 4 pi epsilon naught, that is constant 9 into 10 to the power of 9 Newton meter square divided by Coulomb square. And here this derivation is completed in the part 6 video. Now this is part 7 video. We can discuss step by step. So what is electric dipole? A system of two equal and unlike charges are separated by a small distance is called electric dipole. Here negative charge, positive charge separated by small distance is 2a, and axial line, the line joining the two charges of the electric dipole, is called axial line, and the line passing through the center of the dipole and perpendicular to the axial line, that is called equatorial line. First, here electric potential at a point P, neither axial line nor equatorial line, see between taken. So here we got the potential V is equal to Kp cos theta divided by R square. Try to understand. And continuation, here I am resolving the electric field intensity into two components. One is the radial and another one is the tangential. So along the radial direction, nothing but we wanted to find electric field at a point P at a distance R. It is making an angle theta with the dipole moment vector. What is the dipole moment? Product of charge and length of the dipole is called electric dipole moment. The direction is from the negative charge to positive charge. Here theta is the angle made by the radial vector with the dipole moment vector. Okay, so theta is what here? Angle made by the radial vector R bar with the dipole moment vector from negative charge to positive charge. This is the theta. Okay, so already I told you here electric field is resolved to two components. One is ER. ER is the radial and ET is the tangential. So this is ET. So ET is the tangential, ER is the radial, and next to net value is E net. So this is E net electric field. E net electric field. Net electric field making an angle phi with the radial electric field. Okay. What is phi here? Angle made by the net electric field with the radial electric field. Okay, so here R is the radial, T is the tangential. So R is the radial and T is the tangent. So both are mutually perpendicular to each other. See. Okay, so now we have to find EVD relation with that electric field intensity radial direction and electric field intensity tangential direction. Okay, so try to understand. I'm going to write first EVD relation. So E is equal to minus dou V divided by dou R. So simply E is equal to minus dV by dr. Here we are taking partial differentiation, and first I wanted to take ER value and ET value, so that this is the first radial and second one is tangential, tangent. Okay, so radial value, tangential value, radial is ER and tangential is ET. Okay, Try to understand step by step, we can discuss. See, now we know well known one formula, that is here dr which is equal to r into d theta. This is from d theta which is equal to dr divided by r, that is arc length divided by radius vector. So d theta is the small angular displacement. Okay, so from this formula I wrote this, and here dou r which is equal to r into d theta, I will use this formula, okay, in the tangential value step by step. Now EVD relation I am using, so here ER which is equal to minus dou V divided by dou R. Okay, here I wanted to replace the V value, so ER which is equal to, okay, minus of what is constant here, okay, Kp cos theta is constant. Here minus already is there, Kp cos theta, okay, d by dr of r to the power of minus 2. So this is from denominator to numerator. Okay, so ER value which is equal to minus Kp cos theta, okay, so minus 2, okay, that is remaining value is r to the power of minus 3. Okay, so we got here ER which is equal to this minus is get cancelled, 2 Kp cos theta divided by r cube. Okay, so after partial differentiation here minus 2 is common, and r to the power of minus 2 minus 1, so minus 2 minus 1 is minus 3, and dr by dr is get cancelled, Okay, and continuation we are going to discuss about the tangent value. For this again I am using ET which is equal to minus dou V divided by dou R. So tangential value in which we have to replace dou R value, so that ET which is equal to minus, so 1 by R dou V divided by, in denominator only, d theta. Try to understand. Okay, and next continuation here, see, dV value replacing ET which is equal to minus 1 by R. Okay, so here differentiation with respect to theta, that's why Kp by R square is common, so Kp by R square is common. Okay, and differentiation of cos theta is minus sin theta, so this is minus sin theta. Okay, so try to understand this minus is get cancelled, so ET which is equal to, that is Kp sin theta divided by R cube. So we got two values here, one is the radial electric field intensity and another one is the tangential electric field intensity, and step by step we will discuss, that is net electric field and resultant magnitude first and then direction, and based on the magnitude and direction equations I will find out the electric field intensity on the axial line and also equatorial line. Just a second. Now continuation, magnitude and direction of the net electric field. See, here diagonal square is equal to side square plus side square, then E net which is equal to root over E r square plus E t square. Diagonal square which is equal side square plus side square. Okay, that is now opposite. See, so like this we can take, this is E radial, and this is the E tangential, and this is the diagram. This is E net value. Okay, it is making an angle phi. So diagonal square is equal to E net. Side square is R square. Another side is what? ET square. Okay, see, E net, which is equal, the values are replacing here. Okay, ER value is, okay, one thing we can do, KP by R cube is common in the both equation, and square root of also get cancelled. Square root of also get cancelled. That's why I'm doing KP by R cube. Square root is get cancelled. Okay, into root over, here the value is 4 cos square theta, and here the value is remaining sin square theta. Okay, now E net, which is equal to KP by R cube, okay, root over, this is 3 cos square theta plus 1. See, think practically. Here total is 4 cos square theta. So we can write 3 cos square theta plus cos square theta plus sin square theta. This cos square theta plus sin square theta is 1, and remaining is 3 cos square theta only. This is the magnitude equation, and next we are going to find the result, that is direction. Okay, so direction for this, see, phi, tan phi, which is equal to, just now I gave you opposite by adjacent side. Opposite must be, okay, that is ET, tangential electric field divided by radial electric field. Just now I gave you diagram. Here also we can find opposite by adjacent side. Opposite is what? ET only. Okay, adjacent side is ER. Okay, the values are replacing now. Tan phi, which is equal to, here ET by ER, in which also KP by R cube is common and cancel. KP by R cube in the numerator and denominator common and cancel. So the resultant equation is, that is, numerator is sin theta divided by denominator is 2 cos theta. So tan phi, which is equal to 1 by 2 tan theta. What is theta? The angle between the radial vector to the dipole moment vector. Dipole moment vector is along the axial line. Okay, theta. And what is phi? Here angle made by the net electric field with the radial electric field. Net electric field with the radial electric field, and net electric field is formed by the radial and tangential, we know very well. Okay, so now we got here magnitude equation and direction equation. In the next step directly we will get the axial line and equatorial line of the electric field intensity of the electric dipole. Just a second, I will clean it. And continuation, now using the net electric field magnitude equation and direction equation, we will get the electric field intensity on the axial line. Okay, so that we can take EA, and electric field intensity on the equatorial line is EE. Okay, step by step we can discuss. See, first I'm using the E net equation. But on the axial line, theta must be 0 degrees. On the axial line, theta is equal 0, and equatorial line, theta must be 90 degrees. Theta must be 90 degrees. That thing you should remember. Then values how to replace in this equation. We will get direct equation. So E, A axial line. Okay, KP divided by R cube into this value is, okay, root over 3 into cos 0 plus 1. Already I told you here theta is equal to 0 and cos 0 is equal to 1. Okay, see, then EA, which is equal to KP by R cube into root over, this is 1, 3 plus 1 is 4. Okay, now EA, which is equal to, that we got here, KP, 2KP divided by R cube, and K value is replacing A, which is equal to 1 by 4 pi epsilon naught K value 2P divided by R cube. This is the electric field intensity on the axial line, EA. Okay, where P is equal to what? P is equal to Q into 2A. So charge into length. Length is taken as here 2A. Okay, see, and next we will discuss the direction. So for direction I am writing here, so using this equation. So first I want to explain no space, axial line, then equatorial line. Okay, so equatorial now hold, just I am doing only axial line, no space, and continuation direction. Okay, for direction, so equation is tan phi, which is equal to 1 by 2 tan 0. Here already we know theta is equal to 0 and tan 0 is equal to 0. So here phi also 0. So here phi also 0 because of, okay, theta is 0 and tan phi, which is equal to 0. So phi also 0. Here tan phi, which is equal to 0. Okay, so then phi also 0, and this is the negative charge and this is the positive charge, and this is the electric dipole, and this is the 2A length, and where theta is equal to 0, phi also 0. Where is the axial line? Along the, okay, line joining the charges of the electric dipole. This is the direction of EA. Okay, so EA. So this is completely about the axial line. Next I will explain, just a second, equatorial line, no space, try to understand. And last one is electric field intensity on the equatorial line. Very interesting topic. See, now try to understand on the equatorial line, that is perpendicular to the electric dipole moment vector. So here theta must be 90 degrees. So equatorial line is the line which is passing through the center of the dipole and perpendicular to the axial line. So perpendicular nothing but theta is equal to 90 degrees. So here cos 90, which is equal to 0. So now magnitude equation. So magnitude, tell me. So now EE, which is equal to KP divided by R cube root over, this is 3 into 0 plus 1. Because of cos 90, 0, 0 into anything 0. So EE, which is equal to, we got KP divided by R cube. Okay, that is, okay, 1. So no need to write 1. Then second equation, K value I am replacing, that is 1 by 4 pi epsilon naught. So EE, which is equal to 1 by 4 pi epsilon naught P divided by R cube. And next one is direction. So for direction, tell me, here also theta is equal to 90 degrees. Theta is equal to 90 degrees. Direction formula, tan phi, which is equal to 1 by 2 tan 90. Tan 90 is infinity. So tan phi which is equal to 1 by 2. So this is infinity. Okay, so we can write here phi is infinity. So phi also here infinity. Okay, just a second. Very sorry, here actually here tan phi which is equal to infinity, then tan, here we can write phi which is equal to tan inverse of infinity. So then phi which is equal to 90 degree. Very sorry. Okay, so then equatorial line. So this is the electric dipole. Okay, negative charge, this is the positive charge, and this is the center of the dipole. This is the equatorial line which is perpendicular to the axial line. Okay, so now we got clearly electric field intensity on the axial line and electric field intensity on the equatorial line. Okay, thank you. I will continue with another chapter. Here electric field intensity on the equatorial line is like this. Okay, so this is the electric field intensity on the equatorial line. Phi is 90 degrees. Okay, so we will get like this. Okay, nothing but this is and eta. Okay, thank you.